Atmospheric refraction is the deviation of light or other electromagnetic wave from a straight line as it passes through the atmosphere due to the variation in air density as a function of height. This refraction is due to the velocity of light through air decreasing. The index of refraction increases, with increased density. Atmospheric refraction near the ground produces mirages and can make distant objects appear to shimmer or ripple, elevated or lowered, stretched or shortened with no mirage involved. The term also applies to the refraction of sound. Atmospheric refraction is considered in measuring the position of both astronomical and terrestrial objects. Astronomical or celestial refraction causes astronomical objects to appear higher in the sky than they are in reality. Terrestrial refraction usually causes terrestrial objects to appear higher than they really are, although in the afternoon when the air near the ground is heated, the rays can curve upward making objects appear lower than they really are. Refraction not only affects light rays but all electromagnetic radiation, although in varying degrees. See dispersion in optics. For example, in visible light, blue is more affected than red. This may cause astronomical objects to be spread out into a spectrum in high-resolution images. Crescent moon refracted by the atmosphere as it disappears below the horizon. Whenever possible, astronomers will schedule their observations around the time of culmination of an object when it is highest in the sky. Likewise, sailors will never shoot a star which is not at least 20 degrees or more above the horizon. If observations close to the horizon cannot be avoided, it is possible to equip a telescope with control systems to compensate for the shift caused by the refraction. If the dispersion is a problem too, in case of broadband high-resolution observations, atmospheric refraction correctors can be employed as well, made from pairs of rotating glass prisms. But as the amount of atmospheric refraction is a function of the temperature gradient, the temperature, pressure, and humidity, the amount of water vapor is especially important at mid-infrared wavelengths. The amount of effort needed for a successful compensation can be prohibitive. Surveyors, on the other hand, will often schedule their observations in the afternoon when the magnitude of refraction is minimum. Atmospheric refraction becomes more severe when there are strong temperature gradients, and refraction is not uniform when the atmosphere is inhomogeneous, as when there is turbulence in the air. This is the cause of twinkling of the stars and various deformations of the shape of the sun at sunset and sunrise.